Suppose sides of a parallelogram are a and 2a, one angle is alpha, and the area is equal to a squared. Can we find alpha? First, let's find the formula for the area of a parallelogram. Let A be one side of a parallelogram and HA the corresponding height. Note this triangle. If we move it here, we'll get a rectangle. Now, the parallelogram and the rectangle have the same areas, which means that the area of a parallelogram is equal to the area of a rectangle, and that is equal to A times HA. But what can we do if we have a parallelogram like this one here? We can't just cut a triangle and move it to get this rectangle. What we can do is to cut the parallelogram into smaller parallelograms. And then each of those smaller parallelograms can be transformed into a corresponding rectangle. So in this case also, the area is equal to A times HA. If we go back to our problem, since the area is equal to a squared and this side is equal to 2a, then 2a times h is equal to a squared, which means that the height is equal to a over 2. But now, in this right triangle, the leg opposite to the angle alpha is equal to 1/2 of the hypotenuse, which means that alpha is equal to 30 degrees. In general, the sine of alpha is equal to HA over B, which means that HA is equal to B times the sine of alpha. And since the area is equal to A times HA, then it is also equal to A times B times the sine of alpha. And that gives us the relation between the sides, the angles, and the area of a parallelogram. With that in mind, I leave you with this problem. A rhombus is a parallelogram whose all four sides have equal length. What is the height of a rhombus if its diagonals have lengths 6 and 8? That is all for this video. If you liked it, click the like button, it helps with the YouTube algorithm. And I'll see you next time.